Top 30 VR Game Developer Interview Questions and Answers. Welcome back to the channel. Today's video is all about helping you prepare for one of the most cutting-edge careers in tech, VR game development. Whether you're applying for your first VR role or leveling up to a senior position, this video covers the top 30 VR game developer interview questions, along with strong, clear, and professional answers. Each answer gives you exactly what hiring managers look for: technical skills, VR-specific thinking, and real project insight. Let's dive right into the future of immersive gaming. 1. What inspired you to pursue VR game development? I was inspired by VR because it merges creativity, storytelling, and interactive design in a way traditional screens can't. The ability to create immersive environments where players feel physically present motivates me to build emotional and engaging experiences. As VR technology advances, the possibilities expand, and that challenges me to grow as a developer. I enjoy exploring motion controls, spatial audio, and intuitive interfaces that transform how players interact with virtual worlds. 2. What VR engines or tools are you most experienced with? I'm highly experienced with Unity and Unreal Engine, especially their VR toolkits like Steam VR, Oculus SDK, and OpenXR. Unity is great for rapid prototyping and performance optimization, while Unreal gives me more control over complex visuals. I've used Blender and Maya for 3D assets and tools like XR Interaction Toolkit, Oculus Integration, and VRTK to set up locomotion, interaction systems, and physics behaviors. These tools help me build responsive and immersive VR experiences. 3. What are the biggest challenges in VR game development? VR development involves unique challenges, such as optimizing performance for high frame rates, preventing motion sickness, and designing intuitive interactions. You must focus on spatial awareness, realistic physics, and minimizing input latency. Ensuring environments run at consistent frame rates is crucial because even small drops can break immersion. Another challenge is accessibility, designing for different players, play spaces, and hardware constraints. Success requires balancing creativity with technical precision. 4. How do you prevent motion sickness in VR? Preventing motion sickness starts with maintaining high frame rates, usually 72 to 120 FPS, paired with low latency. I avoid sudden camera movements, unrealistic accelerations, and forced rotation. Instead, I use teleportation systems, fixed-point turning, and smooth locomotion options. I also design stable horizons, reduce visual clutter, and use vignetting during fast movement. Testing with different players is important because tolerance levels vary. These strategies keep gameplay comfortable and accessible to most users. 5. Explain the importance of frame rate in VR games. High frame rates are essential because VR displays directly affect comfort and realism. Low FPS increases input lag, causes visual smear, and can trigger motion sickness. I aim for 90 FPS or higher to keep movement smooth and responsive. Consistency matters more than peak performance. Even minor drops can break immersion. Optimizing assets, reducing overdraw, baking lighting, and using LOD systems all help maintain stable frame timing. Smooth performance improves both gameplay and player comfort. 6. How do you approach optimization for VR platforms? I begin by profiling performance to locate CPU and GPU bottlenecks. For visuals, I use LODs, occlusion culling, bake lighting, and lightweight shaders. On the scripting side, I pool frequently used objects and minimize per frame allocations. I also optimize physics calculations and reduce unnecessary collisions. For VR specifically, I keep geometry simple near the player and only use high detail where it enhances immersion. VR optimization requires balancing realism with efficiency. 7. What locomotion systems have you implemented? I've worked with teleportation, point and dash, smooth locomotion, arm swinger systems, and room scale movement. Teleportation is best for comfort, while smooth locomotion aids immersion for experienced players. I often give players multiple options to suit their comfort levels. I've also built climbing systems, vehicle locomotion, and platform-based movement, where the game environment moves instead of the player. Good locomotion design considers comfort, accessibility, and spatial awareness. 8. How do you design intuitive VR interactions? Intuitive VR interaction starts with mimicking real-world behaviors. I design hand gestures and object manipulation to feel natural, such as grabbing objects with trigger inputs or wrist-based UI. Visual cues, haptic feedback, and spatial audio reinforce interactions. I avoid overly complex controls, ensuring tasks can be understood quickly without tutorials. Testing user experience early helps identify confusing behaviors. A good VR interaction feels effortless and predictable. 9. How do you handle VR physics? I aim for physics that feel convincing but remain stable. I fine-tune object mass, drag, and collision layers to match expected behavior. Using rigid body interpolation prevents jitter, and using physics-based grabbing improves realism. I also limit excessive physics simulations for performance reasons, sometimes faking effects with animations or constraints. Consistency in physics helps players form expectations and improves immersion. 10. What is your experience with hand tracking or gesture-based controls? I've implemented hand tracking using Oculus Hand Tracking API and Ultraleap. It involves mapping gestures, defining interaction zones, and smoothing tracking data to avoid jitter. Hand tracking requires clear affordances like pinch to grab, poke to select, and open palm gestures for menus. I test gestures in different lighting conditions because tracking quality varies. It offers high immersion but requires careful UX design since users expect natural responses. 11. How do you design UI for VR? VR UI must be spatial, readable, and comfortable. I avoid flat 2D overlays and instead position UI panels in 3D space, attached to hands or floating gently in front of the player. Large fonts, minimal clutter, and smooth animations improve readability. I also use gaze-based selection, point arrays, or hand interactions depending on the design. UI should never block the player's view or cause neck strain. 12. Explain what presence means in VR. Presence is a feeling of truly being inside the virtual world. It's achieved when visuals, physics, audio, and interactions blend seamlessly. High frame rates, accurate tracking, and natural controls enhance presence, while glitches or latency weaken it. Building presence requires careful attention to detail, lighting, textures, spatial audio, environmental storytelling, and consistent world logic. When players stop thinking about the controls and simply exist in an environment, you've achieved true presence. 13. How do you test a VR game for user comfort? I conduct structured playtesting with participants of varying VR experience. I observe their reactions, measure play duration, and ask about discomfort levels. I use comfort rating scales to track motion sickness triggers. Testing locomotion, camera behavior, visual effects, and pace helps identify problematic systems. Collecting feedback early prevents redesigning major features later. Comfort testing ensures a game is enjoyable for beginners and experienced players alike. 14. What is reprojection in VR? Reprojection is a technique to artificially smooth frames when the system can't sustain full frame rate. It generates synthetic frames using motion prediction to reduce perceived lag. While it helps maintain comfort, relying on it too heavily can introduce artifacts or ghosting. I treat reprojection as a safety net, not a solution. Maintaining native frame rate is always a goal, but reprojection helps prevent sudden drops during intense scenes. 15. How do you implement spatial audio in VR? Spatial audio creates depth and realism by positioning sound sources within 3D space. I use tools like Oculus Spatializer or Steam Audio to simulate occlusion, reverb, and directional cues. Proper audio design helps players locate objects, feel environmental immersion, and receive subtle gameplay hints. I also balance volume levels so audio remains natural and not overwhelming. Good spatial audio supports presence and player awareness. 16. How do you handle collisions and grabbing mechanics? I use trigger colliders for detection and physics colliders for interaction. For grabbing, I combine ray-based detection for precision and sphere overlap for natural hand movements. I implement attach points to ensure objects snap comfortably into hand positions. For realism, I often use physics-based grabbing, but for stability, kinematic grabbing works better. I test object weight, throw force, and friction to create believable interactions. 17. What strategies do you use for VR lighting? Lighting must balance realism with performance. I use baked lighting whenever possible to reduce GPU load. Dynamic lights are limited and used strategically. I also implement light probes, reflection probes, and mixed lighting for dynamic objects. Clear lighting direction helps players orient themselves. VR lighting must enhance atmosphere without causing glare, flicker, or overexposure. 18. How do you design puzzles or gameplay for VR? VR puzzles should encourage physical interaction, pulling levers, rotating objects, connecting components, or manipulating tools. I avoid flat UI puzzles, instead using spatial mechanics players naturally understand. Puzzle difficulty grows gradually, teaching mechanics through practice, not instructions. Interactivity, sound cues, and environmental hints guide players. VR puzzles must feel tactile and responsive to maintain player engagement. 19. What is your experience with multiplayer VR? I've implemented VR multiplayer using Photon, Mirror, and Unreal replication systems. Multiplayer requires syncing head and hand positions, voice chat interactions, and physics across players. Bandwidth optimization is crucial to reduce lag. I design avatars with minimal geometry to optimize performance. Multiplayer VR also requires social safety features like blocking, muting, and personal space bubbles to create a comfortable environment. 20. How do you ensure accessibility in VR? Accessibility means supporting different comfort levels, disabilities, and play environments. I offer options like seated mode, height adjustment, left-handed controls, movement comfort settings, and colorblind modes. Designing UI with large readable elements helps those with vision challenges. I also test for smaller play spaces to ensure players can enjoy the game without a full room scale setup. Accessibility ensures everyone can participate in VR. 21. How do you approach storytelling in VR? VR storytelling relies on immersion and environmental detail. Instead of heavy dialogue or cutscenes, I use environmental cues, spatial audio, and interactive props to tell the story. Players should feel like they discover the narrative naturally. I also guide their attention using lighting, movement, sound, and level design. VR storytelling must feel personal and player-driven to truly engage. 22. How do you manage memory in VR games? Memory management starts with optimizing textures, reducing unnecessary assets, and using compressed formats. I stream large environments rather than loading everything at once. Object pooling reduces repeated memory allocations. I also keep shader complexity low to save memory bandwidth. Testing memory usage on target hardware ensures the game stays within limits and avoids crashes. 23. What's your experience with haptic feedback? I use haptic feedback to reinforce actions like grabbing objects, firing weapons, or receiving hits. Subtle vibrations improve realism without overwhelming the player. I design vibration patterns that match the intensity and context of events. With controllers, I integrate haptics through built-in APIs. With advanced haptic gloves or suits, I map pressure feedback to enhance immersion. Good haptics must feel purposeful and not distracting. 24. What is FOV and why is important in VR? Field of view, FOV, determines how much players can see at once. A narrow FOV feels restrictive, while a wide FOV improves immersion and spatial awareness. However, pushing FOV too far strains performance. I balance FOV based on target hardware, ensuring comfort and clarity. Stable FOV during movement prevents nausea and helps players orient themselves. 25. How do you design VR environments? I create environments that are detailed but optimized. I consider player movement, interaction zones, and clear navigation paths. Objects near the player have higher detail, while distant objects use simplified models. Environmental storytelling adds depth, and spatial audio reinforces atmosphere. I also ensure environments feel safe and intuitive, avoiding clutter or sharp edges that cause discomfort. 26. How you test tracking accuracy. I test tracking in different lighting conditions and physical play spaces. I check controller drift, hand occlusion, and headset positional accuracy. I use debug tools to visualize tracking points and ensure smooth updates. When issues arise, I adjust interaction design or add additional visual cues. Accurate tracking is fundamental to player trust and immersion. 27. What is your experience with OpenXR? I've worked extensively with OpenXR, which standardizes VR development across multiple devices. It simplifies deployment and reduces dependency on device-specific SDKs. I use OpenXR for input mapping, tracking, and rendering to ensure consistent behavior on headsets like MetaQuest, HTC Vive, and Windows MR. It makes development more scalable and future-proof. 28. How do you handle VR camera systems? VR cameras must represent player head movement accurately. I avoid artificial camera animations or force rotations. For special sequences, I anchor the player in a static position or fade transitions to avoid discomfort. I also implement boundary systems and height adjustments. The camera system must always respect the player's real-world head motion. 29. How do you debug VR-specific issues? I debug using frame analyzers, XR debugging tools, logging, and real-time performance overlays. I test in-headset often to validate experience quality. Common issues include occluded tracking, incorrect coordinate spaces, and physics jitter. I also check interaction collisions and motion smoothing. Frequent iteration helps catch issues early. 30. Why should we hire you as a VR game developer? I bring strong VR technical skills, creativity, and hands-on experience with real projects. I understand the challenges of comfort, immersion, optimization, and interaction design. I work collaboratively, communicate well, and enjoy solving VR-specific problems. Above all, I'm passionate about building immersive experiences that feel natural, engaging, and memorable. I stay updated with emerging VR technologies and bring that knowledge directly into my development process. Thanks for watching. I hope these top 30 VR game developer interview questions and answers help you walk into your next interview with confidence. VR is one of the fastest growing fields in gaming, and being prepared puts you ahead of the competition. If you found this video valuable, make sure to like, subscribe, and comment which job role you want next. Your support helps the channel grow and lets me keep creating content that boosts your career. See you in the next video.